Good evening once again. Welcome to 124th video on misconceptions in physics. Okay, my name is Abdulkar Rao. I teach physics in a school, and the passion is to record videos and post it across YouTube. Of course, passion plays an important role. So whatever we are interested, maybe I thought I would have become an actor sometime, and unfortunately, it was not possible. So I'm doing this before my camera, putting across new ring lights and so on. Okay, so now let us not waste time and continue. I don't want to bore you people with my stories. Okay, so we are working on what you call it as comparison problems. As I told you in the last lecture itself, there are several problems which I have got on comparisons. Okay, so this question is on comparison of paths. The distances traveled are not distances traveled, comparison of the path traveled. Okay, the locus. Okay, the diagram shows the path of a projectile. Where is my locus? Where is my... I'm not able to see this. Just a moment. Diagram shows the path of a projectile which is launched with a velocity v. So this is the path of a projectile. Okay, what is projectile? Projectile is nothing but you take a stone, you throw it like this. Okay, and as a result of it, the particle will go like this. It will go straight away. You are not throwing vertically, you are throwing at an angle. So it will go like this over here. It will go to a maximum height. And from there again, once later, it will return and it will reach a point which is distant away from this. So basically, it starts from here. It keeps on going like this, describes a parabola and then falls. That's called as a projectile. Okay. A second projectile now. So first the projectile is thrown like this. A second projectile has double the mass of the first projectile. One of them has a mass m. The second one has a mass 2m. Okay, it's written here. The first one will have a mass m. The second one will have a mass 2m. I'm just saying an example. Okay, this may not be the right answer. Right. Here resistance is still negligible. Which of the following paths represents the path of the projectile? The original path is shown as a dotted line. Oh my God, this is the dotted line. Okay, this is the dotted line m here, and this could be 2m. So now the question was whether this is correct or this is correct. And the student response, I have not written the student response here. Student responded because he just wrote me, forgot to write it over here. Okay. Okay, so student responded saying that, sir, I thought the answer could be A. The answer could be A. So why is it answer A? The reason is because the student thought that since the mass is too high, okay, as a result of it, gravitational pull will be more for this particle because double the mass. And as a result of it, it is unable to go further upwards. Okay, and hence it will definitely fall down soon. Okay, some students had written me this answer. This was a question which I had asked in one of the test papers. And some of them had written even this also because they thought, okay, so maybe the particles will not be able to move further. And some of them even thought, okay, it could be like this also. So all the three answers equally probable, but none of them have written this one. But the actual answer is B. You might be asking, hey, what is this crazy thing? Two particles having same mass, sorry, different masses, you are throwing it upwards. How can they describe a path? Right? Now, if you remember the projectile's motions equation, you had an equation which is written as y is equal to x tan theta minus gx square divided by 2u square cos square theta. Hey, baapre, kitna bada hai, huh? Big equation. But people who are doing the 11th CPSC, okay, state board or whatever it is, 11th standard, they might know about this very clearly. So what are these? Let me explain these parameters. So this is my projectile. This is the vertical y-axis. This is my horizontal x-axis. X is nothing but the locus. That means, let us say, for example, if I consider this point, the coordinates of this one is nothing but x comma y. Tan theta. Now theta. Now I have described x and y here. Theta is nothing but the angle of projection. So he has taken tan of this theta minus g. What is g? 9.8. X is nothing but the coordinate by 2u square. What is u? U is nothing but the speed of projection. I have thrown it across like this. This is the speed of projection. Okay. And cos square theta we know. So substituting all this value, I can get this value. This means when I say the path over here, the path is governed by the set of coordinates x, y here. Okay. Every point on the path is governed by x and y. Is this x and y dependent on the mass? It's not dependent on the mass. It's completely independent. If it is completely independent, then whether it is a mass m or a mass 2m, how does it matter? It doesn't matter, right? So as a result of this, okay, so you cannot say that these answers are correct. So these answers are completely incorrect, and the only correct option is C. That means a particle with a mass m and a particle with a mass 2m, okay, it travels with the same path. So as it is evident, because it does not depend upon the mass. You take a 1 kg object, throw it at one speed. Okay, 1 kg you cannot throw. Okay, let me take up let us say I have the capacity to throw a small tennis ball. Okay, a tennis ball and a football with the same speed. I throw it with the same speed. Okay, I throw it with the same speed. It describes an arc fast at some point. Then I take a football and I throw it. That also will follow the same point. If I have thrown it only with the same angle and with the same speed. If I do it, definitely it will follow the same location. So this is how the problem is again answered. For those who do not understand this weak equation, I think array physics is full of mathematics. How do I do these kinds of things? Then I'll give you one more example to illustrate what is this. Now, what happens when you throw it upwards is that it goes over here. Now, what is the gravitational acceleration acting here? It's G. It's G here. Okay. This G is constant for both of them. Okay. So if it has to describe a path, it only depends upon what is the G acting here. Once again, you're looking at some abstracting. Let me take one more example. Let us say, for example, no, I think no other examples I can give you. Okay, so let me stop here. Okay, so thus when you learn projectile motion, you will get to know like why, okay, these coordinates are like this. So easiest way to tell you is that based on the equation, you can describe it. Okay, I hope you have got this. And if you have any more questions, you want to know more about projectile motion, you can always get back to me. Maybe I can make a small video on, or maybe if you search for the videos on projectile motion, how do you derive all this, you can easily get it. Projectile motion is not very easy. It's not very tough. Okay. So you can easily understand projectile motion. Only difference is in your 9th and 10th grade, you learn only about one-dimensional motion. Okay. You learn about the position of a particle, velocity, acceleration in one dimension. But when you come to 11th, you have something called as a two-dimensional motion. And this is where your projectile motion comes into. Okay, fine. Let me stop my talk here. If you really like this video, do share, invite all your friends, and subscribe to my channel. This will really help me out for doing more such videos. And you can always write back to me. My email ID is here. My email ID is here. Well, let me move my head. Okay, my email ID is here. You can watch all my videos in this particular website. And this is my phone number, my WhatsApp number especially. I don't pick up calls, okay, randomly. You can just message me if you really want to talk to me, and then maybe I can converse with you. Okay, but many times I'll be busy with either my classes or my school. So I may not be free that much amount of time. But if it is very essential, you can always talk to me. Like, for example, if you say, I want to undergo a coaching under you. Good, no issues. Right. पैसा आएगा तो ठीक है. Fine, dear students. Thank you very much.